years ago, you had to run up against was this kind of old chestnut about the environment is against development. The environment is against progress. The environment curtails advancement, the American dream. And even back then, you knew that there was a whole new opportunity and a whole new future waiting if one could make this change. It was just common sense and good reason that there had to be consideration for an alternative future. There had to be considerations for alternative energy systems instead of plundering non-renewable sources, which would only rip up the land and eventually rip up the most beautiful assets we have in this country for short-term gain. The fact is that there's a tremendous relationship between economics and environmental sustainability. There just is. It can't be denied. So therefore, if somebody doesn't do something now, we're going to wake up one day and be in a situation that's almost irreversible.
The connection between our economy and our environment plays itself out most dramatically where we spend the majority of our workdays. In the United States, buildings devour more than 45% of our energy, 80% of our drinkable water, and about 7 million acres of forest each year. But with an assortment of environmentally friendly building practices, a vanguard of architects, engineers, builders, and business owners is transforming the urban landscape. Across the country, greener buildings are creating bluer skies. Office buildings in every region of the U.S., in both the public and private sector, are beginning to reflect the need to preserve our natural resources and improve a company's bottom line. From New York to Atlanta to Colorado, these high-performance sustainable buildings reflect a growing trend in how we imagine, design, and build the structures in which we live and work. One of the most environmentally efficient of these new buildings is the 15,000 square foot Robert Redford building in downtown Santa Monica, California. The Redford building is home to the Southern California office of the Natural Resources Defense Council, a nonprofit environmental organization. The story of how this building came to be is one of imagination, collaboration, and transformation. Like most stories, the Redford building began with an idea.
The solution to our environmental problems is not to stop building and stop developing our economy. That can't happen, and it wouldn't be a good thing. We need to learn how to grow more intelligently. With this building, what we really did was we set ourselves a monumental challenge to build the greenest building in America, and if we could possibly do it, the greenest building in the world, and to do it cost-effectively.
NRDC has always seen its offices as physical manifestations of its program. So, for example, when we did our New York office, we made it a model of energy efficiency. And then we looked at materials in the Washington, D.C. office. And then we came to this building when it was time to relocate, and we had a chance to do everything at once.
The first thing that the NRDC did was to purchase this building, which is on 2nd Street in Santa Monica. It was a building that was built in the 20s. It was remodeled in the 70s and wasn't in terribly good shape. And you have to imagine how really radical that is. Most environmental groups have been opposed to development and have not understood the relationship between environmentalism and the built world and growth issues that really dominate cities. And for them to choose a site in an existing place, as opposed to, for instance, a greenfield site, they were really already stepping outside of the mold.
In designing any project at any particular location, you will find that there are differences and that there are different challenges. And some aspects of the design of this building may not work at another location, but there may be possibilities that exist elsewhere that didn't exist here. The goal is to understand what the range of possibilities are in sustainable design and to maximize in any given project how many of those elements are included in the project. Santa Monica is a wonderful location in Southern California. It's adjacent to Santa Monica Bay, which is the greatest environmental and economic resource in the region. For a lot of reasons, it made sense for us to locate our office in this part of town, because one of the key elements of that kind of design is a relationship, a connection to the surrounding community in terms of transportation, in terms of energy use, in terms of water use. And that began very naturally to lead into the design process for the building.
During the process, the NRDC wanted very much to have this building one of the best, if not the best, in the United States. So we wanted to implement the LEED rating system and make it a platinum building. LEED is an acronym that stands for Leadership in Energy and Environmental Design. It was developed by the U.S. Green Building Council and is a way to encourage and reward architects, builders, and owners for excellence in sustainable, high-performance design. Platinum is the highest level given and means more than 80% of the environmental measures graded by LEED are achieved in terms of land use planning, water use, energy efficiency, materials, and indoor environmental quality. So this was the objective that we set out to accomplish.
We then began to assemble a design team, consultants, not just in sustainable design, but in building generally. Ultimately, then, we conducted a national search for architects. And there was an enormous amount of interest. We reviewed all the applications, we conducted interviews, and finally selected the design team.
There are big teams of people on my staff, as well as a host of other extraordinary consultants that we were working with that had a lot to say about the building, as well as the NRDC themselves. What we like to do is to work in meetings that are big and broad and inclusive called charrettes.
We had a group of people together very early in the design process, and that's the customer, representatives from the NRDC, people who would actually occupy the space, the full design team, and that's architects, mechanical engineers, electrical, water experts, air quality. We all got in a room to help define what we want to do and start to conceptualize what design strategies might be that were eventually fine-tuned and embodied in this building. It was an opportunity to work with some of the best minds in the country to solve specific problems dealing with high performance or sustainable design.
It was really through this deep marriage, through this common agenda, through this common language that we all spoke, that we supported one another and learned from one another and created a place that no one of us could have made on our own. Well, when you start any building, you do an awful lot of background work. And what we looked at were traffic patterns. We analyzed the nature of the retail on the street and the kind of neighborhood that it is, because we were interested in making what is fundamentally a mixed-use building and one that will balance the uses of the neighborhood. We looked at the proximity to the ocean. We looked at where the water was and where the breezes were coming in. And we looked also at the fabric of the particular building that we had in our hands. It's a long, thin site, and the challenge of getting light into this site was really quite considerable. So what I tried to do was to find some uniting, larger big idea about a building that could really hold not only ideas about how you use light, but really how people were going to use the building. And we came up with this idea of a lighthouse. We started to look at a conceptual design that had these central light wells that marched down the center of the building. And we began to imagine how they would inform and organize the rest of the building. They really are a kind of central spine, they're a central corridor, and it's really shepherding that idea all the way through the process of building that's quite important to me, and then allowing it to be constructed and grow beyond me and live a life of its own.
One of the things that we did, instead of just sort of plowing ahead with a concept and trying to see that through, we actually were able to use both physical and computer simulation tools as a way of really kind of fine-tuning the design. We used that as a way of getting us down to a performance where, we're using 60% less than a conventional building in terms of water, and we're somewhere between 60 and 75% less energy than a conventional building. In addition, the architect created a physical model. We gave that model actually to to Southern California Edison, who had what's called a heliodon, and they were able to actually simulate at various points of the year for all the daylight hours of those various days of the year, what the impact and the light quality and the light level was in the space. It allowed us the opportunity actually to say, okay, well, that doesn't work. This is working really well. What happens if we do this strategy? And really sort of refine the form of the building as a way of responding to daylight that we have in this particular location.
What we were trying to achieve here was a model that could be replicated by others. We're trying to demonstrate that it's possible today, using, in many cases, off-the-shelf technology, to create a building that is sustainable in all its elements and that creates a productive and really pleasant place to work.
Once the design process was complete, the project's construction manager, the Tishman Corporation, began overseeing construction, which took about 15 months to complete. The builders recycled nearly 90% of the materials from the old building, as well as those left over from the new construction. Because of careful planning, the process was no more complicated than that for a typical building. In the fall of 2003, NRDC celebrated the grand opening of the highest-rated LEED building in the world. They named it after Robert Redford for his contributions to the organization as a long-standing member of the Board of Trustees. Across the 5 key areas of sustainability identified by LEED, the building combines innovative ideas with available technology to accomplish its environmental objectives.
Well, in terms of land use, this building is not built out in the suburbs. You know, it didn't encourage sprawl. This site is specifically picked to be within an urban environment. It's near public transportation. It's near residential neighborhoods. And we're rejuvenating a building that was underutilized. So if you look at it that way, this site has been recycled. And that's smart land use.
One of the issues that we encountered was getting a permit from the city of Santa Monica. We're located in what's called a BSC4 zone, which is a special zoning area in Santa Monica intended to encourage pedestrian-oriented activities, restaurants, retail space, so that every building in this area is required to have a certain amount of space on the ground floor devoted to these pedestrian-oriented activities. So what we proposed was an environmental education or activism center, the first of its kind, certainly in Santa Monica, that would be located in this pedestrian-oriented space. The goal of that space would be to bring people in, to teach them about NRDC, to teach them about the work that we do, and to teach them what they can do as individuals to help contribute to a better environment in this community.
The plumbing systems and the water efficiency systems were something that were really interesting on this project because we investigated very early on, again coming back to the original charrette, how we could respond to issues associated with the local environment.
As a response to Southern California's arid climate, engineers came up with a clever, practical water efficiency system. This system captures rainfall through porous tiles on the third-floor terrace, then directs that water into cisterns alongside the building. These cisterns collect and begin to filter the runoff. The building also captures water from sinks and showers. All of this water is purified and then used to flush toilets and irrigate plants. In addition, the building uses a high-efficiency dishwasher, dual flush toilets, waterless urinals, and low-flow plumbing fixtures. Thanks to these technologies, the Redford building places far less demand on Southern California's water resources.
When you talk about energy use in the building, you look at it from several standpoints. The first standpoint is where does the energy come from? You know, this building here has photovoltaics, which supplements the amount of energy that it needs. Instead of drawing power from the grid, it uses the energy of the photovoltaics and therefore lessen the amount of electricity that it requires from the grid.
For the balance of the building's electricity needs, NRDC buys wind energy from the Northwest using renewable energy generation credits. As a result, renewable sources such as wind and solar provide 100% of the building's energy. That means the Redford building adds no carbon dioxide to the atmosphere.
And when you talk about energy use, you talk about conservation. This building encourages a lot of natural ventilation, and we're blessed in Santa Monica to have this refreshing breeze from the ocean, and this building makes full use of that.
By a careful placement of operable windows and with lighthouse towers, the building draws in fresh outside air and displaces stale inside air. It's as if the building were breathing on its own. This passive system requires little upkeep and reduces the building's electricity requirements. When employees are too warm or too cold, they can control their own environments with local thermostats. And if they open a window, a switch automatically shuts off the heating or air conditioning.
With regard to the heating system, it is a hydronic heating system, so it uses hot water. So the heating system that we have is a tankless natural gas-fired system, both for domestic hot water as well as for heating hot water. So there are very little losses, and it responds on demand. In terms of the lighting systems, the NRDC actually was a very active participant in what lighting systems were going to go into the building. We wanted to make sure that the lighting systems were energy efficient, and were appropriate, so which they are. They actually consume about half or less than what you'll find in a conventional office building, so they're extremely energy efficient.
Throughout the building, NRDC used dimmable electronic ballasts, energy-efficient equipment, and energy-efficient lighting geared to specific tasks.
An amazing thing about this building is it emits so much natural light, but in a sort of indirect, diffused way that you could shut off all the artificial light and be just fine, which is really unusual. And I mean, basically the building has 3 major light wells that kind of march down the center of the building and capture a huge amount of sunlight and bring it down not just to the 2nd floor, but to the ground floor. I mean, the overall effect is that it's a soothing place to work. You've got plenty of illumination everywhere you need it.
From a material standpoint, the main consideration is making use of materials we already have, instead of going out to nature and trying to extract some more from Mother Nature. We have a lot of materials in our society, our throwaway society, and we have a lot of opportunities to make use of those materials again in our building.
Reused and recycled material is everywhere you look in the Redford building. Conference room chairs feature seats woven from recycled seat belts. Tables are made from wood grown in sustainably managed forests. Carpeting is a combination of natural and recycled fibers. Flooring is laminated bamboo, a fast-growing grass that's harder and more stable than red oak. In the workroom, the countertop is made from material composed of non-toxic resins and layers of plain and decorative paper. The flooring is natural linoleum made primarily from raw materials such as linseed oil and wood flour. The law library features shelving built with formaldehyde-free softwood resins. The tables are made from native big leaf maple and other reclaimed hardwoods. In the offices, desk chairs are made from recycled aluminum and recycled plastic soda bottles. And on the building's exterior, the design team used a durable material made from cement and sawdust that doesn't expand or shrink and can hold paint 3 times longer than wood. Both inside and out, the Redford building is far less demanding on our natural resources than traditional office buildings.
The occupant comfort is a paramount goal in green buildings. We've all heard years ago about the sick building syndrome, how the indoor air quality is worse than the outside. And it's quite frightening to be aware that the indoor air is many times even worse because it contains carcinogens that were byproducts of the manufacturing process. This particular building, we make full use of low VOC, that's volatile organic compounds, low VOC materials. So the emission level from the products used in this building is negligible or very low. And people that are here, they'll discover that they have less headaches, less allergies.
Along with a healthier environment, the Redford building creates a more productive and collaborative setting for NRDC employees.
It's wonderful coming to work here. Some people talk about wishing they could work at home, and I think this office building is about as close as one could get to working at home. When you enter the building, it feels very open. I feel like when you walk through the building, it flows more than in other office spaces, and I think part of that reason is because you can actually see inside all of the office spaces, which means that there's not the traditional closed door mentality that you might get from some other office buildings.
It's easier to be aware of the daily rhythm in this building because there's so much natural light available, and I think it helps you sort of pace your day better. When I get in the morning, my office is flooded with this great natural light, and as the day wears on and the sun kind of crosses over this light well and then to the offices on the other side of the hall, it serves as a marker for me, and it actually helps the rhythm of my day.
By earning the prestigious LEED Platinum rating, the Robert Redford building demonstrates the highest achievement in green building. But another equally important measure of this building's success and its ability to be replicated is its cost.
One of the things about a sustainable building is that operation costs are likely to be reduced. This building, for example, uses 60 to 75% less energy because of the way it was designed. This building will use 60% less water because of the way it was designed. We maximize natural light. We maximize unfiltered air. All of these things over time will reduce the cost of operation and reduce the cost of the project as a whole. We probably paid a little more for the design in order to make it a sustainable building, but we expect that over a period of 3 to 5 years we'll make that cost back, and then over the life of the project we'll save even more money.
But what people are beginning to find is that green spaces are more productive and that the productivity benefits pay for the extra cost of measures in less than a year, and it increases brand equity and employee loyalty, and it increases customer loyalty because people basically want to reward people who do the right thing. And so all of a sudden, a lot of these difficult to quantify but tangible benefits are beginning to be, people are becoming aware of them and starting to enter them into the equation, and that's why we're seeing a huge buildup of the environmental building movement.
I think the other thing that's really quite important to me about sustainability is that it's an act of permanence. The most important quality of sustainable buildings to me is one where buildings are going to be here for an awful long time, because it's through this dismantling and rebuilding and dismantling and rebuilding that we use the greatest amount of resources and the greatest amount of energy. We're really trying to make buildings that are in some respects quite generic or easily renewable and reusable again.
Had thousands of people come through, and everybody says, I really wish I could work in a space like this. So the word is starting to get out. The consciousness is changing. People are realizing that there's money to be made in this kind of business, and there's money to be saved, and that's a very powerful combination, and that's where the market is beginning to react. It's one of the biggest accomplishments, I think, is just proving that sustainable design is actually superior design, not just as good, but better.
I think there's a sequence that's possible. If you get information to that individual will apply that to their home, whether they're renovating or getting a new home. Once that's done, it stands as evidence of the fact that it's doable and it's attractive and it's far more economical. Okay, so then that goes to the neighbor. Then the neighbor does it, and then friends do it, and pretty soon you have something shaping of a collective. Then the collective becomes a community project. Then the community project becomes a community effort, which turns into a state program, which turns into a state effort, and then it gets replicated on state level and finally becomes a national one.
This is the kind of example that contributes directly to market transformation, because once people see it, they believe that it can be done, and developers can themselves begin to think about how their own projects can be modified to incorporate some, if not all, of the elements that exist here in this project. That eventually will create a market transformation of the kind that we need to see if we're going to minimize the use of resources in society.
Use this, architects, builders, contractors, artisans, designers of all kinds. Understand that there's a whole new and other way to do what they do without losing what they do. That's going to be exciting, but the big thing is it's going to create a sustainable future. The building is hugely important because here it is, a model. I mean, this building is not only a symbol for what can be done, but it's also about possibility. I mean, you come into this building and see, one, how comfortable it is, how good it feels, how sustainable it is, and how without toxins it is, and how easy it is to do. And so I hope that this building will be replicated in a big way because it's doable, and it can happen in every community all across the country.
Green buildings like the Robert Redford Building, no matter where they're built, are about creation without destruction. They celebrate our ability to grow our economy and to sustain our environment. In many ways, they tell us what and how we think about ourselves.
Greener Buildings, Bluer Skies was funded by California utility customers and administered by Southern California Edison under the auspices of the California Public Utilities Commission. For over 100 years, life powered by Edison.